Hi, welcome to TechRanch, a place where we learn and earn technical skills in the most efficient way. Let's make coding fun. Algorithm and implementation. Binary search algorithm. So in this session, we are going to share some information about requirement of the binary search algorithm, an algorithm, complexity of binary search algorithm, flowchart, how it process, demonstration, execution, and a homework for practice project. Now, before we get into the requirement, let's take a look what is actually the searching algorithm. Search algorithm is the most useful feature for searching that particular keyword. We will use these kind of algorithm. It's not just only for the commercial. We can use it in the data analysis, data mining, data discovery, and data structure. There are so many ways you can integrate these type of feature in your application. Now, the most important part of this algorithm is to understand how fast and efficient and accurate these algorithms after implementation. So that is more important for us to decide which kind of searching algorithm you wanted to work on. So there are the most simple searching algorithm is called linear search algorithm. As you can see in this picture here, it was just simply comparing the next element with the key and find out if it is the one. Then it will give you the output that number 5 is what here. This is the location and we found this element. So it's simple like a linear type of algorithm, searching algorithm. Now the complexity is defined with respect to the time and space and how much complicated this process is going to be for a processor. That's what defined in the term of the complexity. Now in case of the binary search algorithm, what we'll do is a fast search algorithm with runtime complexity, and this works on the principle of divide and conquer. So for this algorithm to work properly, the data collection should be in the sorted form. This is one of the basic assumptions or requirement of binary search we need to maintain. The list or the collection of elements has to be in sorted form. Now once the list is in the sorted form, so it is easy for us to just divide the list into two parts and compare the key, the one which you are looking for, at the middle of it, and check it out like if it is greater and less than, and that's how it compared and go to this. So for example, as you can see, this is our sorted list 1 2 3 4 5 6 7. Now the blue pointer is actually comparing with the searching and finding out the key element. So when the green and the blue, as you can see, it is processing. Now before we get into it, let's take a look about the requirement for binary searching algorithm implementation. Now first thing is, when we get the user input, it has to be in the ascending sorted order. Number 2, we need the search for a key. So we need to find out, get the value from the user, the particular number he is looking for. The key position, we will get the key position and check for the key if it is not found or if it is found. Now once the requirement is done, let's take a look at the algorithm. Now I am taking an example of a list which has 7 elements: 3, 6, 9, 12, 5, 15, 18, 21. And this array, which is stored in an array, and this array has the indexing, the position is mentioned in the 0, 1, 2, 3, 4, 5, 6 like this. First thing we need to do is divide. Now for dividing, I'm just simply dividing this list into two parts. 3, 6, 9 is 1 and 5, 18, 21 from the middle. So this middle person is the 12 is going to be compared for the next two lists or next two arrays. We divided. Now 12 is the middle person and the key, suppose we take the 18. We have to find out the number 18. Now when we compare the middle with key, which one is greater or which one is smaller? So based on that, we check the list. As we have the list is in a sorted form, so it is easy to reduce the probability to check the half list of it. Since, as you can see here, since we are looking for 18, which is greater than 12, so we are not going to compare the first part of the list, that is 369, which is lesser than 18. So obviously the processor will understand that 18 is not going to come before the 12. So he's going to compare after the 12 indexing, and next he will increase the indexing, move the pointer from 12 to 15, and then compare the 15 from 18 in the next iteration. And when says that it is still lesser, then the pointer is again going to move up and going to check with the 18, and here the element is found. So this is how it's going to search the binary search algorithm. This is how it works. Now, as you can see, the complexity is reduced, the time taken is very less. We simply didn't compare the half of the list and move up the pointer and compare and find out the key. We get the position number 5. The 18 is stored in number 5 indexing. So this is how the binary search makes the fastest search algorithm with runtime complexity of logarithm n. Now let's talk about the complexity. Complexity means the probability of simplifying the equations with respect to the time. It stands for these algorithms in logarithmic n, where n is the number of bits in a list. Now to understand it in the simple words is the process to find the key in a search algorithm, the time with respect to the complexity, the process time and the number of bits in a list makes it and calculate the complex. With respect to the binary search, it is compared that it is assumed that in a sorted form, and number 2, to divide and conquer process makes it half of the list is already out of the comparison, so it makes it fast searching algorithm. So its complexity is lesser than the linear search algorithm. So the complexity is less means it is the fastest searching algorithm. So for binary search, complexity is logarithmic 1. The flow chart. The pointer starts from the array definition. The list were the elements which is in a sorted form and which has to find out a particular element from that array. So if first we are going to divide, and you can see the indexing is divide in the same array, and compare the key from the middle, and if it is bigger then it goes to this section, the first part, and if it is lesser then it goes to the and position found if the key found. Now let's take a look at the demonstration. So for understanding the binary search algorithm, I just come up with an application, Java application, and it has a class binary search demo which contains a binary search method, the main method. Now this piece of application is divided into again 3 parts. First we are getting the user input, and the input has to be in the sorted, so we can mention it. Searching the key, we need to get the key value what the user need to find out, and we're going to print the position of the key. And inside the main, we are going to simply call the binary search method. Now let's take a look at the execution. So let's take a look at the implementation of binary search algorithm. So first thing, this is my Eclipse IDE. I'm just going to make a new class. It's called binary search demo algorithm demo. And the main method, to make it simple and easy to template. Now the template is ready. Now next step, we are going to define a method, and in this method, first thing we are going to define some variables. First, the last, the middle, and N for number of length of the list, search the key, and array. Now scanner to get the input value from the user. System argument. Now next step, we need to get the value from the user. Enter number of elements in the list. Now since the util package is not included, it's showing me the error. I'm going to simply include the scanner. Now n equals, I need to define the n value, which is nothing but the length of the list. Now array equals, here I'm defining the size of the array, assigning the size of the array. Now once it is done, now next step is we need to get the elements from the user. So along with the indexing for better understanding, and for loop. Now this C is nothing but for the sorting list, displaying the sorting list. So okay, array C equals in dot next int, and what it will do, it will just simply read the next value. Now first index will be 0 and the last index will be your, since the n is the list number of the elements in the list, so the last will be n minus 1, since array starts with the indexing 0. Now the next important thing first is divide. So we need to simply divide the last and first list, and once it is done, now next is all we need to compare the middle with the key. And while loop will basically keep running unless we find out the key value, and here it is comparing, and first equals middle plus 1 will basically help you to carry on if it is not find out. The search is the key, and the search is found. So we can print the message that the key was found at this location. And location is nothing but the indexing, the position of the key which is found by the algorithm. Now if it is found, then we have to come out of the loop, and if it is not, then you need to compare it, and the pointer has to move next. So we can simply reduce the pointer and it will keep, in the next iteration it will again start the procedure and divide that iteration. It will again divide the list into two, so we have to again make it find out the middle and compare it again, and in case if it will not find out again, so this will print the key is not found. So the iteration will simply keep going, keep running. Now, so this is what the binary search algorithm implementation. So you can see first block we get the value. First we got the value from the user. This is my first piece of block of code. The second we simply come dividing and conquering the value, finding out the search value, and if it is not found, then we have to keep running the iteration and dividing again and continuing it. Once it is done, then third we call the main method. We call the class. First we need to make the object, and look at the execution of binary search algorithm demo. It asks enter number of element in a list. So suppose I gave 6. So now you can enter the 6 integers and make sure you enter the sorted list. 1, 2, 3, 7, 9, 10. Now if I wanted to find out the number 9, the 9 is at the location 5. 1, 2, 3, 4, 5. You see? So this is about the execution of binary search algorithm. About the demonstration and the execution of binary search algorithm. So here we have seen the complexity and how we can implement what are the different ways. This is one of them. You can implement this kind of algorithm in number of ways. I just used for loop and condition, if then else. So in the next session we can see the metrics.com online scale converter. So stay tuned, subscribe to our channel. Thank you so much for watching this video. Let's make coding fun.